Need help? Call our cybersecurity team and book a consultation with us today.
Welcome, everybody. My name is Jackie Fukushima, and I am a network engineer here at LA Networks. And today, my fellow colleague Jan Greben and I will be going over some fun facts of Wi-Fi. This is our very first webinar focusing on wireless, but we hope that we can make it into a series and come back with additional content. We hope to start off with a good introductory course today. First off, some housekeeping items. We will be taking questions in the Q&A portion of this WebEx. Please feel free to type in your questions or comments in the Q&A box anytime during the presentation. We will try to address them live, but if not, we can go over them in the Q&A session after the presentation. Just to let you know, this audio will be muted for the attendees, and this webinar will be recorded for future viewing. And after the Q&A session, we have some great information for you guys on some of our wireless services and offerings, so please stick around. Okay, a little bit about our company and who we are. LA Networks is an IT solutions provider based in the Los Angeles area. We've been operating for about 25 years. Our key ingredient is that we are comprised mostly of engineers. We consider this our strong point, and we focus on using our expertise and experience to provide the best IT solutions for our customers. Today's webinar topic is wireless, but we do have a hand in various core technologies, as you can see here. We have engineers that specializes in collaboration, data center, enterprise networking, and security. And on top of that, we also do provide managed services if your organization is looking for a dedicated team to oversee and manage your existing network. As I've mentioned, we are an engineer-based company, and we are very passionate about technology. But moreover, we are a customer-focused, customer-oriented entity. Our commitment is to build and continue the relationships that we have with our customers. A bulk of our engagements are repeats and referrals. And we hope that once you have had a chance to work with us, that you will want to come back to us, and we strive to continue this commitment. Okay, moving on to the core portion of our webinar. Today we'll be going over some sins of Wi-Fi and basically what to watch out for when implementing a wireless network. Wireless as a technology has become increasingly ubiquitous over the years. What started out as something of an experiment and very technical almost 20 to 30 years ago has become sort of a necessity. Nowadays, it has become very common for people to have multiple devices connected to the internet almost entirely from wireless. It's very widely used, and with Wi-Fi routers becoming the norm in most home networks, you have the notion that it's simple to install and set up and assume that it should always work. However, it is also very widely misunderstood and rarely properly implemented, especially in the enterprise networking environment. So today, we would like to lay out some basic and fundamental concepts and highlight some of the sins that we have encountered in our experiences to give our audience some insight on what can happen to a wireless network when things are improperly implemented. With that said, I would like to hand it over to my workmate here, Jan Greben. Please take it away.
Thank you, Jackie. I appreciate that. Hey, everybody. Hope everybody's doing well today. Like Jackie said, my name is Jan Greben. I work here with Jackie at LA Networks as a systems engineer, really focusing on wireless. And today we're going to go over some of the common Wi-Fi fails, or we call them sins, that we've encountered while helping different organizations or working with different organizations with their wireless environment. So we'll start off kind of easy. Wi-Fi sin number one, and that's doing aesthetics the wrong way. Now, as a wireless engineer responsible for the wireless, before we can get to the nitty-gritty of wireless and get involved with configuration or troubleshooting or design, oftentimes first we have to deal with the aesthetic police. And what is the aesthetic police? Well, these are people at our organizations, really architects, interior designers, facility managers, interior managers, even our executive team sometimes. And they really, really care about aesthetics in our facilities or our buildings. And that's a good thing, right? They're trying to create a pleasant, a warm experience for ourselves as employees that work there, for our clients that come in there. But for us as engineers, the challenge is, how do we marry the debate of form over function or function over form? Because I think I speak for myself, maybe for you guys, many of us engineers, we really prefer function over form. But really, there is a happy medium there where we can marry the two and have a good outcome. So starting off there is, what shouldn't we do, right? If we need aesthetics, and that's important to us, and the easy one is don't paint your access points. We've seen this quite a lot, actually. Not only will it just void your manufacturer warranty, but many paints do have some kind of metallic components to them, and metal absolutely will mess with your Wi-Fi, and not in a good way. So instead of painting, what can you do? And our recommendation is cover the APs with a vinyl wrap or a plastic cover. All right, they won't mess with your wireless as much, and they're really a safe way to help the access points blend in without compromising your wireless experience. Another thing we see is hiding access points behind objects, and don't do that. We've seen this in cases where you put an access point up and somebody comes in and tells you, hey, it's ugly here. Can you just can you hide it behind this beam or this post or this whatever? And that's not good, right? Moving at just one access point behind something, what you're really doing is you're compromising your wireless design. Instead of just taking that one access point and moving it by itself, maybe reconsider your design and say, okay, how can I still have a good wireless design without needing to put this one access point right where the aesthetic police told me, hey, this can't go here. And so go back to the drawing board and say, okay, no worries, I'm going to come up with a a new design that's optimal to the space still, but now I don't have an access point in this this random place that somebody said you can't put it here. Now here's actually a couple of examples of those vinyl wraps or plastic covers I told you about. These are actually pretty cool when they first started coming to market. There are vendors out there that they'll let you customize it to your own needs. And so you provide the image, you tell them what size you need, the dimensions, and they'll create the custom skin for you. Right, so if you're, you need to match this brick wall in a bar or this foliage in a zoo, you can do that without, painting them or doing something weird with them, and you still are within best practices of wireless, and you haven't voided your warranty. All right, moving on to Wi-Fi sin number 2, and that's bad placement. So since access points, right, we use the physical media is the space around us, right? It's not a cable, it's not a copper cable, it's not a fiber, glass fiber, it's the space around us. For that reason, it's very important that we put our access points in places, right, where the space around them allows them or is conducive to a good wireless experience, right? So starting off with this picture on the left is this kind of, a give me, but yeah, it's not a good idea. Don't put a metal grate over your access points. Now, I'm sure there was probably good intentions behind this, right, for maybe security reasons or something, but don't do that. Metal, especially metal grate like this, will mess with your access point signal, and you will not get the experience that you're hoping for. And then how about the picture kind of here in the middle with that access point? It's hard to see, but it's in that little red circle, right? That doesn't look too bad, right? Well, that's not good either, right? The problem here is, you see all that HVAC, the lights, the beam, different metal work that's below the access point. We don't want that, right? Try to place your access points below any obstructions, not above any obstructions. And then how about this picture on the far right, right? This gentleman kind of in a lift installing that access point. And this is actually something we see, some regularity. Many people don't think it's a concern until they actually put it up and then they experience it. But, this room kind of looks like an auditorium maybe or a lecture hall. And, what's the problem here? It looks like he's putting it in a good place, but the problem here is the access point is too high, right? That's if you can tell in that picture, right, that's our typical omnidirectional internal antennas, APs that we see by far the most often in people in lecture halls, but that looks like it's about 20, 25 feet high, right? And the way that access point is designed to work, the coverage area is kind of this little flat bubble where it kind of goes down, but really goes out and across. And it's designed to provide coverage in a wide space. It's not designed to provide coverage going downwards. So this being 20, 25, 30 feet up, most of your coverage is up in the air, right? And where are the client devices? They're, at ground level, 3-4 feet off the air. You want to have a design and an access point placement that optimizes your coverage at 3 feet off the ground, not at 15 feet off the ground to where you have to jump and reach for it. And then finally, we have this kind of smaller picture there in the middle. with all the arrows, right? And what are we trying to say there? And there we're trying to say, hey, try to install your access points away from other obstructions. The best practice recommendation is about 3 feet. Now, I'll be honest with you, that's not always going to be possible. As a wireless engineer, you're usually going to be the last one to the party. HVAC is already there, lights are already there, fire suppression, exit signs, whatever it is. So you're the last one coming in. You're not always going to be able to get 3 feet clearance from every other obstruction around you, but just try to put your access point in a little bit of space, right? Don't try to put it directly near an exit sign. All right, directly related is bad positioning. This is similar to bad placement, but the focus really here is in how we're positioning your access points and antennas and their orientation. And you might ask, okay, what do you mean by orientation? Right, well, all access points and antennas, they're designed with a specific propagation pattern. And what that really means is in what direction is the signal being pushed out by the access point. Right, as an example, we mentioned it on the last slide, most access points today are meant to be ceiling mounted. They're usually like the ones you see here. Antennas are inside, they're omnidirectional, and they create, like I said, this little bubble, right? And you can see in the picture in the middle there, right, that access point, that looks like it's installed on a wall, right? But if we talk about the coverage area being this little flat bubble, well, guess what? Most of the coverage is really going up and down, not much of it is going across. And so don't do that. And instead of doing that, if you have to put an access point like that on a wall, instead of, look at this picture kind of there in the middle with the access point on that right angle bracket. So before you install your access points, just take a moment, make sure you understand the propagation pattern, and make sure you're installing it correctly. And then if you need the signal to go into, a special direction, or you have an awkward space to reach, instead of maybe using a typical omni access points like we see here, maybe try to use directional antennas. But with that, we have other challenges. So our recommendation there is don't get too creative with directional antennas and point them whichever way you want to, right? Try to, when you're using directional antennas, use them in the way they were specified. Using, you can read through manufacturer specs or product installation guide, something like that. But so here are a couple of pictures, or 6 pictures of installs we've seen, or pictures we found of directional antennas and how they're installed out in the wild. So I'll give you a moment. There's one here that's definitely correct, and the rest, for the most part, are incorrect. I'll give you a chance to think about which one do you think of these 6 might be the correct way to install these directional antennas. So if you guess number 4, then you are correct. Now, in this scenario, it's actually a pretty challenging environment. That's a curved ceiling in a subway tunnel. It's pretty high up. So we talked about previously how don't use an omni antenna when you're really 20 feet. That's probably too high. So in this scenario, the engineer did a good job. That's probably 25 feet high up in the air. They used directional antennas, and they pointed them at an angle to make sure that even despite the curve of the ceiling, it's still pointing down where the people are. Now, I will say, if you also picked number 1, I would say that is it depends, or it's a maybe. Right? If that's how you have the antennas installed and that's a ceiling, then that would not be correct, right? You don't want your antennas pointing in different directions. But if that's on a wall and facing outward, then actually this is the best practice design to install your directional antennas going up and going down, so you have coverage going outwards to where the people are. Now, let's say, using number 2 as an example, that's not a good idea, right? Don't put your antennas pointing in different directions. And then number 3, honestly, is even worse. Somebody tried to get way too creative, and they not only use antennas pointing in different directions, they also use 2 different kinds of antennas. They have dipoles and they have patch antennas. Don't do that, right? Don't get too creative. All right, moving on to Wi-Fi sin number 4, and that's incorrectly using our channels. So in the 2.4 space, right, which is where wireless kind of started, where most of us, I think, are most familiar with, we have channels 1 through 11 or 1 through 13 available to us. We also have channel 14, but in North America, we're not allowed to use that, and for the most part in the rest of the world, not as well. So 1 through 13, and what can we use? Well, in reality, we don't actually have 13 channels. We really just have only 3. And in 2.4, we really just use channels 1, 6, and 11. And you might ask, well, why? Why are we wasting the rest of the channels? And, well, actually, we're not wasting them. it's just the way that the 2.4, and it's not just 2.4 really, it's just the way radio frequency was designed, that neighboring channels overlap with the channels next to them, right? So if you kind of see in the diagram on the left, channel 1 and channel 2 overlap significantly. Channel 1 and channel 3 still overlap, channel 1 and 4 and 5. It's not until you get to channel 6 that you finally have a channel that doesn't interfere with 1. And then same thing from 6 to 11, 7, 8, 9, 10 all interfere with 6 until you finally get to 11. You finally have 3 channels within 2.4 that don't overlap. So don't just choose random channels, and you'd be surprised, but we do see this where people just use whatever channels they feel like. And so, for example, let's say, channels 3, 6, and 9 sound good to you. Like, yeah, that sounds good to me. I'll install 3, 6, and 9. And you can see in that bottom diagram on the left, right, is that you're going to have quite a bit of an interest. 3 is going to interfere with 6. 6 is going to interfere with 9. So that's not good, right? Don't do that. And then also in the 2.4 space, we only use 20 megahertz white channels. And you might say, why, right? How come not 40? So technically, let's create a scenario where you do use a 40 megahertz white channel, right? So let's say you're using channel 6. You pick channel 6 on this access point. You're like, hey, Jan, I want to use 40 megahertz white channels, and you install that. Also, look at the diagram. So this diagram shows a channel if it's 20 megahertz wide. So if you're going to use a 40 megahertz wide channel, you need to double that. So the width gets doubled. So 6 is not only going to interfere with 7, 8, 9, 10, and 2, 3, 4, 5, it's going to interfere all the way with channel 1, all the way with channel 13. So don't do that, right? If you're using a 40 megahertz wide channel, you're going to have just the one channel in 2.4. So unless you have one access point in your environment, don't do that. And in the 5 megahertz or gigahertz wide channel space, we have some more freedom, right? We have a lot more channels, but we have some challenges or constrictions there as well, right? So if you look at this diagram, it is kind of hard to tell, but if you just look at that blue space, that's the Uni 2 band. We call those the DFS channels. And in a 5 gigahertz spectrum space, right, we actually share that. So this Uni 2 band, we share that with radar. And in our society today, we're actually quite reliant on radar. So in the pecking order of who gets priority, radar gets priority over Wi-Fi. So if you're next to an airport or any kind of facility that has radar or current events, you're going to get kicked off the Wi-Fi. So if you're next to a facility like that, don't use DFS channels. Many of the modern Wi-Fi solutions today, they can tell you if they've seen a DFS channel, so you don't have to guesstimate and guess, hey, I think I'm next to an airport or not. They'll tell you. If you see a DFS channel event occurring, the access point will tell you, hey, I saw it. If you ever see that, I would recommend you stop using DFS channels entirely. Otherwise, your user will have a very, very poor experience. Now, even despite the DFS channels, coming out a very thick part of our channel space in the middle, 5 gigahertz does have more channels than 2.4. In fact, we have 9 channels between Uni 1 and Uni 3. We have 4 in Uni 1, 5 in Uni 3. So you can definitely use those. We have much more freedom to use more channels in 5. But just like in 2.4, I would recommend to stick with 20 megahertz only. I had a networking senior engineer that taught me this one day. He said, some or most rules in networking, they can be broken, or they're allowed to be broken, but only if you know why you're breaking them, the nuance behind it, any kind of consequences behind it. So here, that same thing, right? My recommendation is 20 only in 5 gigahertz. However, if you want to use 40 megahertz wide channels, I don't recommend it, but you can in some special use cases. But just make sure you understand what you're doing. You're cutting down your channel use significantly, and only really do that if you know why you need to do it and you have a specific reason for it. All right, Wi-Fi sin number 5, and that's living in the past with 2.4 gigahertz. Now, the truth is, most of our wireless experiences really started in 2.4, right? If we go back to like the early 2000s, mid 2000s, it was really all 2.4. And there are 2 kind of primary reasons for that. Reason number 1 is 2.4 does just cover more space. It's able to go further. It's able to penetrate solid objects like walls much better. So in our office environments, 2.4 worked better. And probably more importantly, especially early on, 2.4 was just cheaper and less expensive than 5. That's where all the manufacturers went. It was a lot more economical to deploy 2.4 in your environment. Today, however, there's really no difference between 2.4 and 5, especially cost-wise, right? So when you get an access point today, a modern access point, they all come with both 5 and 2.4. You're not saving any money if I don't think you can even buy only 2.4 gigahertz access points nowadays, right? So as we discussed before in the previous one, Wi-Fi SIN number 4, we saw that we have more channels in the 5 gigahertz, so there's a lot of benefit there. And then also we're just able to push more data using 5 gigahertz. So the question is, why use 2.4 gigahertz today? And honestly, unless you have a very specific need or reason to use 2.4 for like legacy devices or for something else, I would say don't rely on 2.4 gigahertz at all. Instead, I'd recommend that make 2.4 gigahertz be your best effort network, right? Design for 5 gigahertz and 6 gigahertz in mind, and then 2.4 is really just your best effort. So don't compromise your design for 5 gigahertz just to make 2.4 perfect, right? If you design for 5 gigahertz and the 2.4 coverage map seems to be, a couple spots here or there, it's not perfect, that's fine. That should be your best effort network, and your 5 gigahertz should be where really the rest of your network and your enterprise devices are at. All right, Wi-Fi SIN number 6, and that's using bad power setting. Now with power, more is not always better. So let's take a picture, look at this picture of this hot dog. Now I love hot dogs, my wife knows this. I love mustard on hot dogs. However, that is way too much mustard. That's just, I would not eat that, right? So transmit power on our APs, it's kind of like that. And I also use the Goldilocks story analogy. There is such a thing as too little power. There's definitely such a thing as too much power. But there's this kind of happy medium where it's just right. And usually if you just let your access points get set to the automatic setting, they'll do that. Now you might ask, why is max transit power bad, right? If I boost up the transit power, won't I have more coverage? And actually, you'd be correct. Yeah, you would have more coverage with more transit power. But like I mentioned before, that rule that my senior engineer told me before, you should only break rules if you know why you're breaking them and what happens. So if you want to change the default setting and you want to change your APs to transit power, just understand what's going to happen, right? So let's say you have an access point, right, and it's at a default setting of 12 dBm. Let's say that's the automatic. That's what the controller chose. And you go in and you say, hey, no, I want to change it to max. And let's say your access point's max is 23 dBm. So you change it to 23 and you're so happy and you get more coverage. But what occurs? Well, for one, we create something called asymmetrical transmit power. And what that means is, okay, so you've changed the transmit power of your access point to 23. Good job. I'm proud of you. That's awesome. But guess what? The client that the access point is talking to was transmitted 13 decibels, and it's still at 13 dBm, right? It's not going to magically change to 23 just because you change the access point to 23. And the scenario that creates really is one-way communication, right? Because the access point is broadcasting at 23, it's able to go super far. But your phone or your laptop, let's say, is at 13 dBm, it tries to talk back to the access point, and the access point just can't hear it. It's just not far enough. And in networking, outside of super rare cases, we don't want one-way communication. That's not a good thing. And then another problem is sticky clients, and it's directly related to that. And you ask, well, what do you mean by sticky client? And really what I mean is a client stays with one access point for much longer than it should. Right, so let's use the same example where you change your access point to 23 dBm. Let's say you're on your client device and you walk and you get further away from that access point and you start getting closer to another access point. And this access point is much better to you, it's much closer to you, and really your client device should make the decision and say, hey, I'm going to roam to this new access point, it's much closer to me. However, since your transit power is so high, your client device still thinks it's getting great signal from this access point. It's now 70, 80 feet away. And so it's going to stick to that original access point and not make the roaming decision to this new access point, and you're just going to get a worse experience because of it. This also creates significant interference, right? Because with all these APs at full transit power, their reach and their coverage area, they become much larger than they should. And so access points will begin interfering with other access points. So in this scenario, as your client device starts walking to this other access point, it's trying to make the roaming decision. It can't. Well, now those two access points are interfering with each other. And your device is hearing signals from two different access points at the same time. And let's say, your design didn't have enough channel use, you might now be hearing on the same channel from multiple access points, and your communication going back out, it's going to be jumbled. It's going to be, some part of it is going to be going to one access point, another point to another access point, and that's not good, right? So instead, if you need better coverage, I would recommend to increase your number of access points And if you have a hard-to-reach area, instead of just boosting up the transmit power, don't be afraid to use directional antennas. All right, Wi-Fi send number 7, and that's not doing wireless surveys. Guys, we see this one a lot. And our recommendation is do wireless surveys. And to answer why, let's use an analogy, right? So I'll use myself as an example. I don't have very good eyesight. I haven't had it since I was a kid, and it's gotten slowly worse. I'm wearing glasses right now, and honestly, if I take my glasses off, I'm not legally blind, but pretty darn close to it. Okay, so now pretend you're me, right, and you're driving at night, and you take your glasses off. This picture is honestly a pretty good visual of what it would look like. Honestly, nowadays it's probably even worse for me, but that's not a very good picture, right? You wouldn't feel comfortable driving like this. So now pretend that, you had a good night out with your friends, you called an Uber, and I'm your driver. And you get in the car and you're like, hey, and you're like, hey, and I tell you, I'm not wearing glasses, I'm not wearing contacts. I don't know if you'd feel comfortable with me driving you like this, and that's not a good idea, right? And so same thing for wireless surveys. Doing your wireless without doing a survey beforehand or during, it's the same thing when you're driving at night with glasses. You're blind going into it. And we talked about it before, right? In wireless, our medium is not cabling, it's the physical space around us. So it's a good idea to get an idea, survey the space around you, around the access points, and get a good idea, hey, is this conducive to good wireless? Where should I put my access points in? And so I recommend to do surveys both pre-deployment and post-deployment. And so before you deploy your wireless, do a predictive survey, get an idea of how the signal will move, how to propagate through the area, right? If possible, use some kind of modeling software. Personally, I'm a fan of Ekahau, but there's other modeling software out there. If you want to go all out, you can, put your AP on a tripod, walk around on what we call an AP on a stick survey, and good idea before you deploy. And then after you deploy, do a validation survey, right? Make sure that, hey, my design actually makes sense. I modeled this out, but now we deployed it. How does it act in the real world? And do a validation survey. And then even for troubleshooting, we use surveys sometimes too for our spot check. It's one of the first steps in troubleshooting, right? Is let's cancel out, eliminate the physical layer. We do it in cabling as well, or in switching networks. One of the first steps in troubleshooting is it connected, right? In wireless, when we start troubleshooting, well, let's just eliminate that there's a physical problem. What does the survey look like? Let's make sure we don't have interference or anything else going on. And so leading in from the surveys, right? The next one is Wi-Fi send number 8, and that's not designing based on need. And so let's say you follow our advice and you go, hey, I'm going to do a survey, and you do a survey and you do a design, and it's great, but it's still possible to miss a step. The truth is, wireless is a pretty resilient technology, so it can usually work just out of the box for the most part, but it doesn't really begin to truly shine until you create a wireless network that's customized to fit your needs. And so as an example, story time, we often get asked about supporting voice over Wi-Fi networks. Now, most modern wireless networks today, like I said, are pretty resilient, and honestly, it can probably support voice over Wi-Fi pretty decently. But if you really rely on voice over Wi-Fi and you really want a good experience, I'd recommend a design that actually optimizes that experience and is not just good enough, right? So for voice over Wi-Fi, you say, okay, Jan, what do I need to do? Well, one of the things we want to design with voice over Wi-Fi is we want to have something called intermediary APs. And these are APs that help with, the roaming decision. Let's say I'm walking down a hallway and I need to roam to the next access point. With voice over Wi-Fi, we want to have an access point that's there in the middle, really kind of like an exchange point that hands off one client to the next access point, to the next access point. Because with voice over Wi-Fi, one of the most important things is latency and jitter, right? And if we have good roaming decisions that are happening quickly, we can lower our latency and jitter. If we have poor roaming decisions going on, the user will experience that and feel that as they're on their phone call. Right? Another need we often get asked about is location data or tracking. And that's a completely different use case with a lot more requirement for design, because for location, how do we get location data? Well, it's just like when we were in elementary school, right? We triangulate. So to triangulate, you need 3 access points to always have some kind of touch to a client device. So you're going to need to increase the number of access points in your environment significantly to be able to find location data and deliver it back to you. And then you can also just have a business need, as simple as user density. And that takes us to, the coverage versus capacity conversation. Right, so on the left here, it's a coverage-based design, right? We just want to have coverage over a whole building, and we have that. And then the right is a capacity-based design. And so capacity is when we have a lot of clients, right? Nowadays, we have, many of us have 3, 4, 5 devices that are connected to the Wi-Fi, right? A laptop, a mobile device, a watch. Who knows? It seems like we're all now just walking pieces of mobile devices that connect. And so it's very possible that, this coverage design, it worked for a long time. It may still work for you if you don't have, a lot of devices connecting to your Wi-Fi. But if you're one of those organizations that has users coming in with 3, 4 devices, then this coverage design might not be enough for you, right? And you need a capacity design just to be able to handle the number of clients per access point. But honestly, you don't even have to choose, this is not an either-or conversation. You don't have to do only coverage or only capacity. It's also possible to do a hybrid between the two, right? For example, let's say you're an organization that really doesn't have a lot of users coming in with clients. You just have an office-based environment. Offices are far enough spread apart. It's not cubicles. You're okay with a coverage-based design. But then on this right side of your building, right, you either have conference rooms back to back to back, or you have an auditorium, or something where you have a lot of people in a confined space, and the 2 access points there on the right aren't able to handle 200, 180 clients or whatever it is. You can do a hybrid between the two, right? You can do a capacity-based design where you have a lot of user density, and then do a coverage-based design in the same building where you just need coverage and not capacity. All right, Wi-Fi sin number 9, and that's treating indoor and outdoor equally. Now, the fact is, outdoor and indoor access points are different, and there's a good reason, right? And so we recently had a client come to us and said, hey guys, management asked us to provide coverage to this new outdoor space, right? They were going to build a new outdoor space, kind of in a little courtyard area they had, and they said, hey, management asked, can we have Wi-Fi out there? And they happen to have a lot of, spare access points, indoor access points. And so he said, hey, can I just take these access points that I have that are just spare, sit on a shelf, do nothing, and just put them outside? And honestly, the answer is no, you can't, right? Outdoor Wi-Fi requires a lot more consideration and involves a lot more details. For one, mounting is a lot harder outdoors. It's no longer as simple as just putting it in a drop ceiling grid. We're now mounting to a wall, a pole, or something else entirely. And then also the elements of the outdoor come into play. We want to make sure outdoor APs are waterproof, right? They're resistant to heat, dust, other factors. And then something as simple as even the distance to our switch comes into play. When we're inside, for the most part, 300 feet for a Cat6 cable is plenty, right? But when you start going outside and you might have an awkward path to get there, it's very possible to get beyond 300 feet. And now we start talking about, hey, do we put an intermediary small switch out there? Or do we now run a fiber run just to that access point? And then something also that's sometimes forgotten, but best not to ignore, are regulatory laws for outdoor Wi-Fi. And so the FCC in America here cares greatly about Wi-Fi propagation, or it's really all radio frequency propagation, and they have specific laws for that. And so when you're inside your building, you really have, for the most part, have autonomy to do what you want, for the most part, right? When you're outside your building, you have to follow FCC laws, right? So they have regulations on, for example, where can you point, where can you not point? What's the max transit power of that access point? So how far does the signal propagate? So those are things to consider if you need an access point outdoors. All right, moving on to Wi-Fi sin number 10, and that's using consumer Wi-Fi equipment. I'm not sure if that's surprising to you or not, but actually we get asked this question a lot, right? Somebody comes and says, hey, why do I need to spend $20,000, on a new Wi-Fi network? Why can't I just go to, my local Best Buy and buy some, 6, 7 access points for $1,500 bucks? And honestly, the answer is, like most things in networking, it depends, right? True, obviously, consumer Wi-Fi is way less expensive, way, by a factor of 10. But it really depends on your needs, right? So if you need Wi-Fi for a small branch office far, far away that's, a tiny 2-room place that's 1 access point, hey, I'm not going to recommend it, but if you want to go ahead and get consumer Wi-Fi, at least I'll understand it, right? But the truth is, honestly, outside of dire circumstances or super low budget circumstances, I don't recommend it at all, because it's one of those things that it can be great when it works, but it's really a pain in the butt when it stops working and you need to troubleshoot. And so for one, let's say, it breaks. you don't have, with consumer Wi-Fi, you don't have the same, access to support that you would with a, a Cisco or an Aruba, right? You're left dealing with consumer-based support that honestly probably hasn't run into scenarios like you run into. It's not meant for this kind of deployment. And then let's say you're troubleshooting, you don't have access to good logs, or really sometimes you don't have access to any logs, and you're in the blind to try to figure out, hey, this one client can't talk to this one access point. I have no idea what's going on. There are no logs getting back to me. There's no way for me to check. And then another thing is, it can work if your needs are simple, but the moment you need some advanced features, right, all of a sudden you're stuck. And I had this happen to me in a previous life where we had this one client. He had a lot of small offices kind of all over the state, and they had to open up this one office really quickly. And he said, hey, Jan, I'll just go the consumer Wi-Fi route. And, thank you for your recommendation, but thank you, but no thank you, we'll just go this way. And I was, hey, you understand why, why you shouldn't do this, but obviously it's your organization. I'll go ahead and do it. And then lo and behold, right, the same organization said, hey, we actually want to expand some of these smaller offices, because the thing was they had a lot more space, but they only opened up like 2 rooms. And then their business grew, which is fantastic for them, but now all of a sudden they wanted to grow that same location, right, from 2 rooms to 3 or 4. And this didn't happen in one place, right? This was at like 20 different branch locations, to all of a sudden it needed to grow from 2,000 square feet to, in some places, 10, 15,000 square feet. And the thing with consumer Wi-Fi is it's not very scalable, right? It's not designed for that at all. It's designed for a home environment, a couple access points, and usually just your home. It's not very good for multiple branches. And so that client, they had to migrate. They had to migrate to enterprise-grade Wi-Fi just because the consumer Wi-Fi was no longer able to provide for their needs, and that was a sunk cost for them. And so with consumer Wi-Fi, I wouldn't recommend it, honestly. It's not worth the hassle. I know up front it looks like it's budget-friendly and you pay less up front, but you really end up paying more over time with support, with eventual migration, with whatever issues you run into. All right. Now, sin number 11, and that's confusing hype versus reality. So the truth is, wireless isn't, it falls victim to the same thing that networking does, or IT does in general, and that's we have a lot of buzzwords and hype. And so it's a little tricky sometimes to understand, hey, what is relevant and what isn't. And so, for example, let's look at the slide, right? How do you know if things like multi-user MIMO or multi-gigabit or, 8 spatial streams, 8 antennas, or, wide channels, how do you know if those are relevant to your organization? Honestly, I hope no manufacturers are listening to this, but the truth is probably none of these are really relevant to your organization. The reasons behind why each one of these might not be relevant, they're pretty technical. So this is a topic that, I really enjoy. I don't really think we have the time in this webinar to jump into each one of those, right? Your users, ultimately, they don't care about some fancy acronym, right, or the number of spatial streams. They just care about connectivity and what their experience is like. Now, so for example, hey, is 6 gigahertz, is that hype versus reality? And my answer would be, no, I think that's reality. It's not hype. The reason there is because, right, in 6 gigahertz, as it's coming out now and probably will be more ubiquitous within the next 2, 3, 4 years, we have so much more channel use that your users will just be able to get more airtime, less competition, that's a real improvement within Wi-Fi that will actually give you a better experience. So this topic is one, honestly, that we see a lot of confusion about. People get confused when marketing terms. Even, seasoned wireless vets. I mean, I was one of those. When multi-user MIMO first came out with 802.11 Wave 2 AC, it's like, oh man, this is going to be the next best thing. This is going to be awesome. One access point is going to talk to 2 clients at the same time. This is great. And a lot of people thought that, in theory, that sounded great. And then in reality, we saw it and we're like, well, that doesn't really work out in reality as much. It's actually very, very hard for an access point to talk to 2 clients at once, just from a physical standpoint, ignoring, any of the protocols or the configuration. So if this is a topic that, interests you, I think we'll try to do a topic or a whole webinar on just this topic in the future. But if it does interest you, don't hesitate to give us a ping, holler at us and tell us, hey, this is interesting. Maybe at some point we'll do, this one slide as a whole webinar, because there's a lot to talk about here. All right, now moving on to Wi-Fi sin number 12, and that's ignoring radio interference. Now this is actually one that comes up a lot when we get asked to troubleshoot, especially like spotty Wi-Fi. Somebody comes in and says, hey, we have a great design, they implemented it, but then your users start using it and it's a crappy experience. And it's like, hey, what gives? I thought I did a good job. Well, honestly, it may not be your fault. Sometimes it's interference from non-Wi-Fi devices. You might have a great design, but just other devices messing with you. Because the thing is with wireless, speaking of the FCC, in the 2.4 gigahertz and 5 gigahertz bands, like why is Wi-Fi there? Well, that's because those are called the unregulated bands or unlicensed bands by the FCC. And why unlicensed? Really because for the most part, the FCC says, hey, within your establishment, you can kind of do whatever, right? And we have a lot of, for that reason, we have a lot of devices using those frequencies and not just Wi-Fi, right? Microwave ovens, that's a famous one. Microwave ovens use 2.4 gigahertz. So back in the day, I don't know if you guys had 2.4 Wi-Fi when that we only had 2.4 Wi-Fi in the house, and then somebody turned on a microwave oven. That would get people off the network, and that's not magic. That's just because it uses the same radio frequency band, right? Things like cordless phones, Bluetooth, radar we spoke about before, right? Radar uses 5 gigahertz, and if a radar event is occurring, it'll kick you off the Wi-Fi. So we share the Wi-Fi space with all of these devices. So we have to be cognizant of what's around us, what's in our buildings that could be interfering with us. So a story I have here, right, is we recently had a client and they came to us and said, hey, we designed a Wi-Fi on a controller, it looks fine, but we're having issues, we're not sure why. And so I came out with my trusty Wi-Fi analyzer, and so that's kind of a snapshot of what it might look like. And took our wireless analyzer, and I came out just to see, hey, what do we see in this space? And so, and this particular facility was kind of further away from other buildings. It was a building kind of on its own, so we didn't expect to see much outside interference because there's quite a bit of distance between other buildings. But then we walked in and we started analyzing the wireless, and especially in a 5 gigahertz space, which was strange, right? Most of the Wi-Fi interference is, you kind of see on the list to the left, most of the interference is in 2.4, but we came in and we saw a lot of interference in the 5 gigahertz space. And we thought, hey, what's going on? And we inspected it further, and we discovered that, so this client, they had a lot of digital signage, right? TVs with digital signage. So as their clients came in, whatever they needed to see was on the TVs, and it looked pretty awesome. It worked great for them. But these TVs were all throughout the facility, right? And what we realized is, for the digital signage to communicate, whoever the installer was, right? It wasn't a network team. It wasn't a network engineer's fault. But whoever came in to install the digital signage, they had installed these little Spectrum set-up boxes to communicate. And these Spectrum boxes were transmitted in 5 gigahertz space. They were set to max transit power, and they were using wide channels of 80 megahertz. Right? So if you remember one of our first slides when we talked about wide channels, 80 megahertz wide means they were interfering with a lot of channels at the same time, also set to max transit power. And so it wasn't a network engineer's fault, but you can bet that all these set-up boxes were absolutely messing with their signal. So once we discovered that, moved some of the boxes around, right, they didn't have to be in 5 gigahertz, all of a sudden their experience got a lot better. And so related to that, Wi-Fi sin number 13 is not ignoring our physical interference. Right? And so you might look at these two pictures and you're like, what is this about? I understand Wi-Fi interference, but what is physical interference? Well, so believe it or not, both of these pictures, they're actually real examples of real world case scenarios where we ran into some physical interference. Right? So the picture on the left, that's a common area at a university, the university campus. And at some point, well, after the university was open, the administration decided, hey, we actually want to provide Wi-Fi to our students in this common area, right? They thought that this space could be good for students to stop, do some homework, or just be on the phone, whatever. But it was a nice area for the students, and the students loved that idea, right? I think it was actually an idea brought up by somebody in student council that said, hey, we want to have this space and we want to do our homework here and gather there. And so it said, hey, that's a great idea. And so they brought in a wireless engineer, and they did the right things, right? They did a survey. They tried to see, hey, where should we put the access points? They did a design based on need. They really did kind of coverage-based design. And so the engineer came out. They decided to do this over winter break. right, where the students and the teachers would not be in the way. Now here, I'm in California. There's not much of a difference between winter break and summer break, but this particular university was in the Northeast in Massachusetts, and so there's a big difference between winter and summer, right? In the winter, it was cold, it was snowy, but it was winter break, so hey, they decided this is our chance. They had a nice 4-week-long winter break, so they decided to deploy it then. They did a survey, they did a deployment, and for quite a while, actually, it worked perfectly, right? So the network engineer, they got quite a few pats on the back. They got some kudos. The administration was happy. The students were happy. It worked really well. The students enjoyed it. Now, in the winter, the students weren't stopping by very much and stopping there and doing homework, but it still worked, right? And as it started getting warmer, it was still kind of fine. And then sometime in like April, towards the end of the semester, they started getting complaints from students like, hey, there's some dead spots in coverage areas. Like if I walk here, I'll begin to lose coverage. And the engineer thought, okay, well, maybe the external antennas got nudged because they used external antennas, directional antennas to provide coverage. He thought maybe somebody played around with them, maybe they just got hit, whatever it is. So he came out to look, and actually, no, all the external antennas were still, aligned right and oriented correctly. And so they weren't really sure what was going on, but the issues continued to get worse and worse until somebody finally figured it out. So I don't know if you've guessed it or not, but the issue was the trees. In the winter, when the surveying was done, the design was done, deployment was done, in the winter, there were no leaves on the trees. And so everything worked perfectly. But as springtime and summer came, the trees regained their leaves, and the Wi-Fi started having issues. And the reason for that is, what are leaves made of? Well, leaves are mostly actually made of water. All this water will absolutely have an effect on the way signal propagates. Right, so in the winter, no leaves. Springtime comes, leaves show up. All of a sudden, it's a very different physical environment. Your wireless design was created for an environment with no leaves and no water blocking everything. All of a sudden, all the leaves come back, and you have significant dead spots. That's one story. And then the story on the right, you're like, okay, that makes sense to me. But what does a garbage truck have to do with Wi-Fi, right? Well, this one is actually equally perplexing. So we had a client, they owned a facility that was split by kind of this small little back alleyway. And the main part of the facility where most of the employees were in the front. And then they kind of behind this back alleyway, there was a smaller building that really was mostly used for storage. And there were 5 or 6 different organizations all kind of next to each other, and they all had the same kind of setup, where the front was the main kind of store or main place where people worked, and the back, basically almost everybody just used it for storage. It was kind of small. It was primarily, there was no cable infrastructure run there. But this organization, they were growing, and they said, hey, instead of expanding to a different location, we already have this kind of other smaller space behind us. Why not use that, right? But instead of needing to, run new cabling or trench new cabling, I said, hey, how about we do a 2-point wireless bridge between 2 buildings? It's a lot more economical. Why not that? And I said, yeah, that sounds good. And so they did it. And initially, it worked great. However, they began to have intermittent issues, and not just issues with bad service, but a complete network down would occur seemingly, rarely, but also intermittently. They couldn't nail it down why this was going on. The APs weren't going down, the controllers weren't going down. They weren't sure what was happening, and it began to impact the business activities, right? Because most of these occurrences were happening in the morning as people were on conference calls, and a 5-10 minute outage was a pretty big deal for everybody in that small building to lose access to the network. And I don't know if you've guessed it by the garbage truck, but that back alley was being used by the local garbage truck company to pick up the garbage from all the different businesses around. And the alley being kind of awkward and small, it just so happened that the garbage truck would stop directly in front of that wireless bridge as they, went and picked up some of the smaller trash cans from the businesses that they couldn't reach. And so the truck would stop there 5-10 minutes at a time and literally block the wireless bridge. And, and don't care how great your wireless is, it cannot get through a garbage truck, right? As we look here, right, the different kind of barriers we have, you can see metal there is very high in the interference level, kind of towards the bottom of the list. Wireless signal will not go through metal, right? Concrete is also similar. We see buildings with concrete. For the trees, you see water. It's kind of in that medium level. It absolutely will mess with it. And so all this to say is that, when you do your wireless designs, consider potential physical interference, right? So things like wood and glass that we have in our buildings, in our interior building materials, they're not as bad, but definitely watch out for those corner cases where something like that happens and fully blocks your Wi-Fi signal. All right, so moving on to Wi-Fi sin number 14, and that's ignoring end user devices. Now, we spend a lot of time worrying about access points, controller, stuff like that. But ultimately, how do our users interface with Wi-Fi? And that's through their own devices, right? Through mobile phones, laptops, watches, whatever it may be. And, your access point, your controller, we can't control the end user device. You can't, that's the end user device. So we can make recommendations. The access point and the controller can make recommendations, but it's up to the device itself whether it wants to roam or associate with an AP or associate with an SSID. So this can make it hard to troubleshoot because you're not just troubleshooting the physical space like the APs and controllers. You also have to pay attention to the health of the client devices themselves, right? What's the age of the device? Does it have outdated software or wireless drivers? Is the user connecting to the right network, right? I know this may make you laugh, but we've had occurrences where people complain about, bad Wi-Fi, and you come to help them out, and you realize they're actually trying to connect to the Starbucks network from across the street, right? So make sure they're even connecting to the right SSID. So don't forget about the end user devices, right? Try to migrate away from legacy devices, upgrade your software drivers, upgrade your software itself, and then make sure you're connecting with the correct setting. And our last Wi-Fi sin, that's Wi-Fi sin number 15. And that's bad security practices. Now, although last, this should never ever be least. Security is very important in our networks, and that does not stop being true in our Wi-Fi networks. Looking at this, these are the security protocols, right, we had in Wi-Fi. Definitely don't use the very now antiquated WEP or WPA, the original WPA. Instead, try to use WPA2 or the recently released WPA3. And then our recommendation also is not to use PSK, right, the pre-shared keys, especially in organizations, right, to use WPA2 Enterprise, 802.11.1x. Use role-based access with a radius server, right, so Cisco ICE is a great example of that, but there are lots of other good solutions available. And then for personal use, when you need to use a public wireless, try to use a VPN when possible, so you're not just going over the wireless naked. All right, so that ends our wireless sins. Did we have any other Q&A? If you guys haven't submitted any Q&A, feel free to submit it in that Q&A.
We have a few that we can ask you.
Sure.
That we have as we're typing in responses right now to the Q&A. One of them was, what kind of antenna can I use if my ceiling is 14 feet high?
So that's a good question, and that does occur, every once in a while. I think we talked about it in one of the slides. Try not to use those omnidirectional APs. They're not designed to go that far down. If you have occurrences where you're trying to get down 14 feet or more, don't be afraid to use directional antennas. They are harder to design for. That's something we can help with for sure. But if you're comfortable with that, use directional antennas, point them down where you need to go. And that's a much better use case than just trying to use omnidirectional internal antennas.
Definitely. Let's see. Here's one in our chat that I'm not going to type the answer out to. Matt's asking, what options are there for huge high open spaces like warehouses? Any alternatives to using directionals down the aisles? I think that's a similar.
That's a similar. So there's honestly multiple ways to do warehouses. We've seen them. We've done them multiple ways. There are ways to shoot it down the aisle. There are ways. One way we actually did recently is use directional antennas, but kind of create cones, right? This warehouse had very high ceilings, and we used directional antennas pointing almost straight down. So instead of on the side of an aisle, pointing almost straight down, and it creates cones of coverage almost similar to how we have omnidirectional antennas indoor, where we have kind of, our little circles of coverage. So that's one way to do it, but there are multiple ways to do warehouses. If that's something that, you want to talk about, for sure we can take it offline. and just look, take a look at specifically your warehouse and what it looks like and what's the best use there.
Okay, here's another one. Is it best practice to do manual channel assignments or to let the controller automatically select them? Huh?
It's a good question. I'll take that back to the advice that I got from our mentor before, and that's, only break rules if you know what you're doing and you know the consequences. For the most part, our controllers are very good at making decisions, whether that be what channel to use, what transmit power to use. So try to, honestly, I would recommend try to use the automatic setting. That is usually in 99% of cases good enough and good for most people. If you know what you're doing and you're a seasoned wireless vet, you know the consequences, you know what you're doing, absolutely you can play around and set up your own transmit power, your own channel assignments. But for most scenarios, I would not recommend that.
Okay. I guess here's a kind of a corollary to that. I have my wireless power set to automatic. Are you saying I should manually reduce power levels?
Probably not, right? And same kind of answer applies there, is if you know what you're doing and you're setting it downwards for a specific reason, that's in a specific use case, and do it, right? Knowing the consequences that it's now manual and you now need to manually adjust probably other access points as well. But for the most part, I wouldn't recommend that either. Let the controller pick that. Now, especially nowadays, controllers have gotten a lot smarter than they were in the past. Even things like, Meraki access points or Aruba that are controller-less, they still have a controller, right? It's up in the cloud and it's still making those decisions quite well. For the most part, let the controller make those decisions. If you have a specific, use case you're wondering, like I said, don't be afraid to ask us a question. We can take it offline and take a look at a specific use case and see if maybe, for you it makes sense.
Okay. Surveys cost too much money. Are they really worth it?
That's a good question, but I'll take it back to the slide I had, right, about driving blinds in the night. You wanna make sure you're doing the right thing, right? If this was, in switching networks, we really care about our cabling. You don't just pick up a random cable off the ground and go, this looks good, I'm gonna plug it in. Right, we don't do that. We try to get all the same cables, right? Whether that's Cat 6, if we're doing fiber, we choose, single mode, multi-mode. We don't just pick up a random fiber cable. Same thing for wireless, right? So in wireless, our medium is the space around us. It's not the cable. So we want to do a survey and get a good idea of what we're dealing with.
Okay, I think we're a few minutes over, but I got a good one here. Are you saying I should just shut down 2.4 completely?
This may be controversial, but I would say if you can, do it, right? If you have no client devices using it, well, what's the point of just broadcasting it for no reason? If you do have, some people still using it, I would advise try to migrate them away, right? If you have some legacy devices, try to upgrade those and move them away. Really just use 5 exclusively and not 2.4. I do understand, right, that's not always possible for everybody. So for those where you need to have 2.4, you can keep around as the best effort. But I'm in a party of if you don't need it, get rid of it.
That's good. Well, I guess we maybe need to have a webinar on that as well. How to detach yourself from legacy wireless. Okay, I think we're kind of at our end. Jackie.
All right. Well, thank you very much, John. That was a lot of good information, and I hope that our audience here got a lot of takeaways from that. The 15 sins that we just went through are pretty basic concepts of Wi-Fi, but again, they can be misunderstood and misconfigured in a lot of implementation, and that is why we kind of recommend getting professional input into your wireless setup, even if it is for an existing network. And this is where LA Networks can help. We do provide solutions for your wireless network. We do Wi-Fi surveys, Wi-Fi health checks for existing networks, consultations on new designs, and also wireless managed services. So yes, if you are looking for any of these items, please reach out to us. For those of you who are joining us today, and for those people who are viewing us later in the webinar, we are offering a special wireless health check package. This includes a wireless site survey for a single location of up to 4,000 square feet, a review of the wireless controllers for best practice settings, and also a security review of your wireless network and the clients. For a limited time, we are offering all of this for a discounted price of $1,500. So please contact us via the information on the screen slide below. We will be looking forward to working with you and hope to bring some increased efficiency into your wireless network. So this will conclude our wireless webinar session for today. I would like to thank everybody here again for joining us. We had a great time sharing our knowledge with you, and we hope to see you again very soon. Thank you very much.
Need help? Call our cybersecurity team and book a consultation with us today.